We've now attached the animation to our entity, and we've got our entity moving with the animation. So our animation is driving our controller. However, we currently only have a single animation, and our player can only move in a single direction. We'll not be fixing all of the problems now. What we're going to do now instead is set up a more complete animation set. This animation set comes from the old deprecated standard assets pack, and this is a very basic set, but it does allow for basic locomotion. In my animator window, I'm going to create a new state from a blend tree, and I'm going to delete the walk animation state. I'll then create the transitions between my idle state and this blend tree. These transitions will work in exactly the same way as the previous animation. This transition will transition from our blend tree to our idle, and we'll do this if the speed is less than 0.01. We'll then transition to our blend tree if the speed is greater than 0.01. I'll make sure that neither of these transitions has an exit time. I'll enter the blend tree node. Within this node we have a blend tree, and this blend tree is currently empty. In this case we're going to be blending animations on a 2D plane. Currently the parameter which we have here will be speed. This is not the parameter which we need, so we will need to make other parameters for this, but we'll do that later. Before that we'll need to set our blend type, and I'm going to set this to use a 2D freeform Cartesian grid. Essentially this will give us an X and a Y axis. This should give us two parameters which we can set, and both of these will currently be set to speed. So I'll add two parameters, and these parameters are going to be float parameters. The first of these parameters will be called horizontal. The second will be called vertical. I can then set the parameters of the blend tree to be driven by the horizontal parameter and the vertical parameter. We should now be able to add motions to this. Motions are essentially animations. After we add at least two motions, we should get a visualization which will display how our animation will be working. If we were to change our blend options to 1D, you'd see that we get a different style of blend option here. However, we're going to be setting two-dimensional blending, which will work better for the kind of animation which I'm trying to do. I'll add a number of extra motion fields. We could try and add our animations to the folder directly, but this won't actually work. This is because the animations themselves are not actually the animation. What we really need to be looking for are the animation clips. I'll move my project window next to the inspector to make this easier to work with. I'll then set the project to only show animation clips. I'll then lock this view. This will give us access to all of our animation clips. I'll start by adding the walk, and I'll add this to our first motion. This will be followed by a run. We should be able to test our animations at any time in the view at the bottom of the blend tree. I do, however, want to replace this model, so I'll drag the FBX for my prototype character onto this viewport. I'll return to my animation clips. I'll then start adding my turning animations. First we'll have our stand quarter turn left. This will be followed by a stand half turn left. This will be followed by stand quarter turn right and stand half turn right. The order here is not strictly important, as the values that are calculated will be based off the animation themselves, but it is still useful to try and order these logically, and I'm trying to order them in the speed that the character moves. To actually calculate our animations, I can use the compute positions option, and I'm going to compute my positions using speed and angular speed. These will set our animation blends based off the movements of the character, and it will calculate values for pos x and pos y. Pos x will be driven by our horizontal parameter, and pos y is going to be driven by our vertical parameter. So these speeds will correspond with the values for these parameters. We should now be able to preview some of this. If I now move my horizontal slider, I can change between my turning animations. And with the vertical slider, we should be able to move our character forwards and backwards. And we should be able to get blending between all of these animations. I can continue updating these parameters. Next, we'll have our walk left sharp. This will be followed by my walk left. This will be followed by the walk right sharp, which in turn will be followed by the walk right. I can then update the speed and angular speed settings. We should now have better control over the blends for the walk-in, especially the turns for our walking character. This is essentially the minimum which we'll need for an animated walk set. So if we're going to drive our character purely through animation, this would be the basic set which we need. There are of course many alternative ways of setting up a character animation set. This purely blended option is only one of many. After this, I'll add 4 more motion fields, and these will contain the turning animations for our run. We'll have our run left, and we'll have our run left sharp, our run right, and our run right sharp. I'll revert my interface, and I'll once again update the calculation for the animations. So one of the things which you should observe from this is we have a maximum horizontal value of about 2.4 and a maximum vertical value of about 5.6. These values matter as we are going to use them to determine the speed at which the character is moving. To use these parameters, we're going to need to update our script, and the script we are updating is going to be the system for the player. We're going to be updating the character where we update our animator. I'll do this after I calculate my speed. Here I'll add another value of the speed, and this will be set with animator.animator.setFloat. This will be setting my horizontal value, and I'll be setting this with my right stick.value.x. This will be followed by animator.animator.setFloat. The first argument will be vertical, and this will be set with my right stick.value.y. We can now return to Unity and we can test, and this unfortunately is not working particularly well. I do not have much beyond the walk at the moment, and I have a very basic turn for the character. The reason for this relates to the parameters within our animation blend that we discussed earlier, those being the maximum values for our X position and our Y position. So I'll return to my script. I'm going to multiply the Y value by 2.7, and I'll multiply the X value by 6. These are not strictly accurate, but they should be good enough for what we're doing now. Both of these values should be set to float. I can save again, and we could test again. We should now be able to test again, and I'm now getting the kind of control that I want. The reason for this change is that the value of the sticks will be between 0 and 1, or at least approximately, so these values will never actually reach the values within the blend state. Multiplying these by the values in the blend state sets that to be the maximum value for the stick, which will allow us to use all of our animation values. Although I have made a mistake and I've set the values the wrong way around, the horizontal value should be multiplied by 2.7 and the vertical value should be multiplied by 6. I should now be able to move my character and turn my character. This, however, is not the easiest thing to work with, as the movement is not related to either my camera's position or the character's position. All the movement is occurring globally relative to the blend space. So everything is happening in world space, and this would actually be fine for certain types of controls. For example, if we had a scrolling top-down camera, which was not able to rotate around the character, but was always going to move relative to the character's position. So I want to base this movement based off the position of the character, as well as the rotation of the camera. And we'll start taking a look at that next.